give you, let me zoom in a little more, they give you a little picture, which is nice. Better than nothing, I suppose, huh? 1 into 10^2, approximate Centauri, 5.9 trillion miles, 4.22 light years from Earth. And we have to find how many miles. Oh. The mean distance from the Earth to the Sun is this. Okay, part B. All right, part B is the trig. On my part A is just conversion. What is going on here? Okay. All right, so let's draw the picture. So we have the Sun. We have the Earth at some time. We have the Earth at a different time. We have our star way out here. And our parallax is this angle here. Theta. So the first part, part A, is telling you that this star, Proxima Centauri, is 4.22 light years from Earth. So that would be this distance here. And then it says if 1 light year is about 5.9 trillion miles, how many miles is Proxima Centauri from Earth? So part A is just getting you to convert light years to miles. So they tell you 1 light year is 5.9 trillion miles. So if you want to know 4.22 light years, what would you do?
Times it by 5.9.
See how if you have your conversion factor, just take 4.22 times 5.9 trillion. Someone want to give this to me?
It's
24.898 trillion miles. That's a lot of miles, I guess. Then it says the mean distance from Earth to the Sun is about 93 million miles. What is the parallax of Proxima Centauri? So they're telling you this distance here is 93 million miles. And they want you to solve for this theta here, which is what we call the parallax. So what could you set up to solve for theta in part B?
So this is just a triangle.
Yeah, you know this guy, and you know this guy is 24.898 trillion. So we know this guy. The implication is that we measured the way this is set up, these form right angles. So I have a right triangle, and I know the opposite side and the hypotenuse. Right, if you're focusing on theta, this side would be opposite, this side would be hypotenuse. So then we would set up sine of theta equals 93 million. I have to be careful here. I'll fix this up in a second. Over 24.898 trillion. Unfortunately, these aren't in the same units right now. Right? 93 million over 24.898 trillion isn't going to be what I actually want to divide. I mean, 93 over 24.898 isn't what I actually want to divide. So I either want to write out all the zeros here, or I want to convert them both to millions and both to trillions. So what guys want to do?
Trillions? Or trillions?
So, do you know how many trillions are in a million? Or how many millions are in a trillion? You don't want to
A
guess.
million?
So, alright, let's write out the zeros again. So, 93 million looks like this, right?
It's a million.
So then, in order to get 1 trillion, this is 1 trillion. 'Cause this would be, oh no, this is 1 billion. Ooh. There we go, right? 1 million, 1 billion, 1 trillion. So we need 24, and then 898, and then 00009.
Go back to 4th grade.
Hey.
Zeros.
Hey, you know, if you haven't done it in a while. So you actually have to divide this out, or these guys aren't going to matter. Right? So you'd have to divide 93 by 24, 898, 000. 24 million. Once you do that, I can finish the problem. If not, then it'll be a pretty small decimal. Very small. What do you want me to do?
What do you have a calculator?
Did you get it?
I got it.
Which one?
It's 0.00000. So 5 zeros.
1, 2, 3, 4, 5.
3735.
3, 7, 3, 4.
I don't know if I did it right.
Let's find out.
Anybody have confirmation? You have confirmation? Beautiful. So then how do we get theta?
Inverse.
Sine inverse. Right, you gotta get rid of this sign, so you sine inverse both sides. So then theta will equal sine inverse of 0.123453735. Probably in degrees, I would assume they want it. What do we get? Anybody?
0.000214.
0.000214?
Yeah.
Degrees. I have no astronomical experience, so I cannot try to lie to you about the great meaning behind this problem. But I can tell you there's a right triangle here and we can solve for data, so go trigonometry. What else? Did they agree with us? Or did they fall aside or something? They agreed? They good. I was like, so, he always abuses me. Anything else I can do? You guys look at 8.5 at all? Yeah, go ahead.
Number 64.
Mm-hmm. 8.1?
Yeah.
Mm-hmm. Let me pull it up real quick. Finding the bearing of a ship? Sure. Mm-hmm.
Let me do that one.
Sure. Oh, actually, I can do number 64 for you. Because I gave you something like exactly like number 64 for your quiz. I can do number 63 for you.
Oh, okay.
I can do number 64 for you next week.
Okay.
Oh. Let me see. Does this guy turn 90 degrees? All right, bearing. Yeah, this this is fairly similar. Let's do 62. The DC-9 aircraft leaves Midway Airport from runway 4 right. Very important information. His bearing is 40 degrees east of north. After flying for 1/2 mile, the pilot requests permission to turn 90 degrees and head toward the southeast. Permission is granted. After the airplane goes 1 mile in this direction, what bearing should the control tower use to locate the aircraft? So, let's draw a picture. Never eat stop eating waffles. Okay, so our airplane leaves from runway 4 right, which I'll go ahead and move off of the diagram, at a bearing of 40 degrees east of north. So here's north, 40 degrees to the east. Looks like this, with this guy equaling 40 degrees. So just so I have it, I'll label this part right here 50. Before I go too far. Then it says the plane travels or flies for 1/2 mile and then requests permission to turn 90 degrees and head toward the southeast. Okay. So he travels for 1/2 mile. So this distance here is 1/2. And he turns 90 degrees and head toward the southeast. Oh, well, he can only turn 90 degrees this way or this way. So which one do you think is southeast? Downward, right? So he turns 90 degrees toward the southeast. And then he goes for what, 1 mile? 1 mile in this direction. So 1 mile in this direction. 1/2 mile up here. 1 mile in this direction. And the question asks, what bearing should the control tower use to locate the aircraft? So the control tower is back here where he started. This is where the plane is now. So the bearing that the control tower should use, if you measure it from north, the bearing that the control tower should use would be this angle here. Bearings are, we always measure from north or south. So, what can I do? So I have a right triangle, and I know this side length, and I know this side length. This side, this whole thing's 50, but that's not so useful, so let me erase it. I thought it might be this now. If I can find this angle in my triangle, then I can add that to 40 and I will have my bearing. So what I'm going to do is focus on this angle. And according to this angle, I have opposite and adjacent. So we can set up a tangent argument here. Tangent of theta should equal what? Opposite over adjacent, 1 over 1/2. Flip that up, you get tangent of theta equals 2. So what's theta? How do you get theta? Tan inverse, right? You got to get rid of the tangent to isolate theta, so you tan inverse. So in degrees, someone get me tan inverse of 2. What is it?
63.43.
63.4. Oh, interesting. Oh, interesting. What's that mean?
It's more than one. It's more than
My drawing's kind of crappy.
Because my scale is
Not too scale. There you go. So, okay. Since it's 63.43 degrees for this angle, it actually is going to come down. Since you only have 50 degrees left here, it's actually going to come down a little bit this way. So it goes way out here.
So then would we start from south to write down the bearing?
Now, I'm not going to be super picky here. I'll take either bearing. Okay, so that there's two ways to do the bearing here. Either you can start from north, like I originally had planned to do, and if you start from north, how far would you have to go to the east? You'd have to add the 40 to the theta to get your bearing. So 40 plus 63.43, 103.43. But since you went over 90 degrees, this would be kind of a silly way to do it. You could use south instead. So what I did to get this 143 is I started from the north. I know I have 40 degrees here, and then theta was 63.43, so I had to add it. Or another way to write this, you can start from the south. If you start from the south and come out to here, what would this angle be? You're going to have to take 180, right? This whole angle right here. This whole angle right here is 180. And you know that this portion of it, this portion of it right here, is 103.43. So 180 minus 103.43 will give you this leftover portion. So 76.57. So that would be south. That would be measuring from the south. So this guy, to get this guy, I took 180. And I subtracted my bearing, which was my original bearing, which was 40, and I subtracted theta. After solving for the angle inside the triangle, I had to convert that back to a bearing. Either by adding the 40 and measuring from north, or by subtracting both of these from 180 and measuring from south.